Today another important session about the 100 days concepts. Okay, there are 100 concepts for NEET. Okay, we are going to discuss another important topic from the regulation of kidney. Okay, yeah, regulation of kidney, which is elimination of nitrogenous waste in the physiology topic. We are going to discuss. This is the most important regulation of kidney and function of NEET. How it is regulated? It is regulated by hormonal, which is physiological control of GFR rate and blood pressure. Okay, yeah, if come to this, guys, just look into this. This is the hormonal influence going to take place where the physiological control of GFR and BP, blood pressure. What is GFR? What is blood pressure? We are going to discuss about this. Okay, what are the main regulatory centers? Main regulatory centers of the kidney, which is the urine formation. If there any blood pressure increase or decrease, okay, how they can impact on the urine formation. There is a hypothalamus, which is the influence of the regulatory center, and juxtaglomerular apparatus, that is JGA, and atria, which is heart, ANF. Okay, these are the main regulatory center. One center is hypothalamus, one center is JGA, which is in the nephron, one center is in the heart, atria, right atria, where ANF release. Okay, these are the main center of the regulation of urine formation, regulation of kidney itself. Okay, what is GFR? We are going to discuss. Okay, yeah, what is hypothalamus? Hypothalamus mechanism. Hypothalamus, they release ADH. Okay, antidiuretic hormone. That is, if they releases, there is a changes of the hormone receptors. They can the fluid changes. They can receptors. They can detect the fluid ionic ion concentration changes. Okay, we will discuss. The osmoreceptors detect the ionic changes in the fluid. It stimulates hypothalamus to release ADH, that is ADH vasopressin from the neurohypophysis. Vasopressin also release neurohypophysis. There is a neurohypophysis, adenohypophysis, which is there is a pituitary gland, anterior pituitary, posterior pituitary, and posterior pituitary, which is neurohypophysis, they release vasopressin. If they release ADH, what happened? If the ADH release, water reabsorption going to take place where the nephron is collecting duct and distal convoluted tube. Where is the water reabsorption going to increase? Where? If the ADH released by hypothalamus. We will going to discuss. Okay. Also, it is causes vasoconstriction and blood pressure increase. There is a GFR rate will increase. There is a high fluid volume. ADH inhibition is going to take place later on. Okay, we are going to discuss this. Okay, yes. And next Renin-Angiotensin-Aldosterone system, we can call it as RAAS system. If the GFR will decrease, what happened? JG cells, where they can release, what they can do, and what is angiotensin? Angiotensin 1 is what? Angiotensin 2 is what? What they can stimulate? Aldosterone is what? We are going to discuss. Okay. After that, ANF, the blood flow where the increase in the atria, right atria to flow, which is increase into the heart can release ANF. ANF, what they can do? Vasodilation, BP decrease, GFR decrease. It is act as check on the RAAS, completely opposite to the RAAS. We are going to discuss these guys. Okay, yes, today class we are going to discuss this. Okay, first hypothalamus. Okay, yeah, So guys, GFR rate, the regulation of GFR, glomerular filtration rate, glomerular filtration rate, okay, GFR, the regulation, how they regulate. Actually, just look into here. Okay, this is efferent arteriole. This is efferent arteriole. Efferent arteriole. In this condition, what happened? There is a blood flow. The blood flow which is increased here, blood flow which is increased here, actually the GFR rate is actually 125 ml per minute. 125 ml per minute. Actually, the GFR rate is, that is net filtration pressure, which is 10 mmHg. In this condition, net filtration pressure 10 mmHg. In this condition, optimum the GFR rate is 125 ml, okay, ml per minute. 125 ml per minute. If the blood pressure increase, okay, in the artery, and blood pressure increase, the efferent arteriole flow will increase, blood flow will increase. In this condition, if the blood flow increase, the GFR rate will increase. GFR rate will increase, mean efferent arteriole, it can be dilate. Mean the efferent arteriole is like relax. The efferent arteriole relax. If it is relaxed, the blood flow will increase. That leads to the GFR will increase. GFR will increase. if the GFR will increase, there is a flow of calcium ions will increase. Flow of calcium ions will increase. In the efferent arteriole, okay, that leads to the contract the muscle, contraction going to take place. In the efferent arteriole. Efferent arteriole, there is a calcium channel open. If the calcium ion open, these muscles are going to be contract. So flow will be decrease. Flow will be decrease. So that is the auto-regulation. Auto-regulation of GFR. Auto-regulation of GFR. Actually, GFR will is 125 ml per minute, where the net filter pressure is 10 mmHg. So if the blood flow is going huge through the efferent arteriole, that is increase of net filtration pressure. In this condition, there is the receptors going to give signal into the efferent arteriole to release the calcium ions. If the calcium ions release, there is a contraction, muscle contraction is going to take place, that leads to the size will be decrease of efferent arteriole. Okay? Yeah, where actually this efferent arteriole muscle contract. Initially, efferent arteriole muscle contract, and there is a efferent arteriole muscle going to relax. In this condition, where the net filtration rate will increase. Yeah, auto regulation going to take place when, I am going to write here, when efferent arteriole muscle relax, same times condition blood pressure will increase, where and glomerular GFR will increase, blood pressure increase, GFR increase. The conditions are what? The conditions when, condition number 1, when efferent arteriole relax, muscle relax, and efferent arteriole muscle contract, this is the condition only. Blood pressure will increase, flow of blood pressure will increase, GFR will increase. In this way, there is a auto regulation is created. In this condition, auto regulation is created. Auto regulation of GFR. Who can auto-regulate? There is a calcium ions release. Calcium ions created efferent arterial contract. In this condition, GFR, blood pressure decrease, GFR will decrease. Blood pressure will decrease, GFR will decrease. This is the auto-regulation. This is the auto-regulation. Okay? We are going to discuss the next mechanism. I hope you guys understand this. Yeah, next. When blood pressure decreases, what happened? What happened? If the blood pressure decreased, what happened? What happened? If the blood pressure decrease, efferent arterial. Okay, in this condition where the blood pressure will decrease, GFR will decrease. Okay, if blood pressure decrease, GFR also decrease. GFR will also decrease. In this condition, what happened? If the GFR will decrease, there is water, the fluid is very slowly they can move in the PCT part. The fluid very slowly, if conditions I have to write. If GFR decrease, first point, if GFR rate decrease, the fluid very slowly move from PCT very slowly move from the PCT. In this condition, there is more ions reabsorption takes place PCT part. Okay? Yeah. If the more absorption is going to take place PCT part, yeah, next in the DCT, in the DCT, there is receptors finds low level of Na sodium ions, that is the receptors cells called macula densa. Receptors cells or macula densa Macula densa are the cells which is modified epithelial cells. Modified epithelial cells. So, first, if the GFR decrease, there is a fluid is very slowly move in the nephron. In that condition, there is a PCT part. PCT part 70 to 80% reabsorption is takes place. This is the reabsorption in the PCT part. There are ions move into the blood vessel in the capillary. Sodium ions are huge, enter into the blood vessel. In that condition, there is a DCT part, low amount of sodium. In this condition, there are cells, okay? There are certain cells, group of cells in the DCT part. These cells are macula densa. They can observe there is a salt content is very low. In this condition, what happened? We are going to discuss now. Are you clear up to here? Are you clear? If the GFR decrease, there is a fluid very slowly enter into the PCT part. There is a PCT part, huge Na will absorb, okay? Huge Na will absorb in the PCT part. If the fluid which is enter into the up to the DCT, there is a sodium ions are very low. There are certain receptors in the DCT part. That is the receptors are the macula densa. They recognize there is no sodium ions, very low. That is the macula densa. What's happened? Okay, we are going to discuss next. What happened in the macula densa? Okay, this is PCT, this is DCT, collecting duct, Henle loop. Okay. Okay, yeah, guys. Okay, yeah, in this condition, there are certain cells in the part of efferent arteriole. This is efferent arteriole. Efferent arteriole, which is near to the glomerular, the efferent arteriole, there are cells which are endothelial cells of the efferent arteriole, or called juxtaglomerular cells, juxtaglomerular cells, plus these macula densa cells at the place of DCT, macula densa of the DCT, juxtaglomerular cells and macula densa together they release a hormone called renin. They release a hormone called renin. Okay, renin, which is produced in the between the macula densa and JGA cells. Okay, these together we can call JGA cells, juxtaglomerular apparatus, they release the hormone called renin. Okay, renin, which they can enter into the blood renin enter into the blood and finally they can reach into the liver. Okay, yeah. They can reach into the liver, guys. Liver. In the liver, there is a glycoprotein, okay, called angiotensinogen. Angiotensinogen. This is the angiotensinogen. If the renin reach in the liver, this renin reach liver, this angiotensin in the matters of renin turn into the angiotensin. Angiotensinogen turn into the, nogen mean inactive. This is inactive form, okay. Already in the liver there is a chemical which is called angiotensinogen that can be activated by renin. That can be activated by renin. This is the renin, angiotensin converted into angiotensin 1. Angiotensin 1. Yes, ma'am. Just about 5 minutes. Angiotensin 1. This is the angiotensin 1. They can reach liver. Sorry, they can reach lungs, angiotensin 2, they can reach lungs. In the lungs there is a enzyme is called ACE, angiotensin convertase enzyme. Angiotensin convertase enzyme. Angiotensin convertase enzyme in the liver, in the lungs, okay, that leads to angiotensin 1 converted into angiotensin 2. Angiotensin 2. Angiotensin 2. Angiotensin 1 is inactive. This convertase enzyme, angiotensin convertase enzyme, that release angiotensin 1 converted into the angiotensin 2. This is active form. Active form. This is act on kidney, act on kidney. There is adrenal cortex. Adrenal cortex, adrenal gland, adrenal gland. They can act on above the kidney. There is a gland called adrenal gland, okay, that is release aldosterone. This adrenal gland release aldosterone. Aldosterone. Finally, which is renin, renin to convert into the angiotensin and finally release aldosterone. This is the system called RAAS system. This is called RAAS system. Guys, first renin which is produced through the JGA apparatus, that is the renin that can be reached into the liver. In the liver there is a chemical called angiotensinogen, that is the angiotensinogen that can be active where the renin, if the reach into the liver, if that active, that release angiotensin 1, that is the angiotensin 1. They can reach lungs. There is a lungs where there is a enzyme in the lungs, angiotensin convertase enzyme. Okay, that is the convertase enzyme. This inactive angiotensin 1 converted into the angiotensin 2 active form. Angiotensin 2 active form. This is the angiotensin 2 act on aldosterone. Adrenal gland, that is the adrenal gland which is release aldosterone. What is work of aldosterone? What is work of ADH hormone? What is work of ANF? Pura 3 hormones are going to influence of the regulation of the kidney, where it is first, if the blood pressure decrease, what happened? GFR will be decreased. If the GFR will be decreased, what happened? There is a macula densa, there is a cells which is specialized cells in the DCT parts recognize the NaCl decrease. If the sodium decrease, they can activate to release renin along with GGA apparatus. That is the GGA apparatus. They can release renin. Renin is the reason for the angiotensinogen converted into the angiotensin. That is angiotensin. There is a enzyme, angiotensin convertase enzyme in the lungs that is activate angiotensin 2. Angiotensin 2 act on, there is a adrenal gland release finally aldosterone. We are going to discuss tomorrow class what is the function of aldosterone, what is the function of ADH hormone, what is the function of ANF. Tomorrow class. Okay guys, you have to follow. This is the zoology, this is the NEET wall. Give you the best classes, pure 100 topics for NEET covered, 180 of 180 for the zoology. Thank you.